Welcome back, dear friends. Lots of things have happened since the last video. As you'll know, I don't even know whether you can see, yeah, you can see that. I've got this moving up and down, I've got the switches on and all the rest of it, but it was very noisy. Just a little brief recap, because I didn't know what I was doing with these stepper motors. Originally I was using this, one of these, to drive them off. This is a standard H-bridge driver, which allows you to connect a coil one way round and then the other way round, backwards and forwards like that. And I learned lots of things through that, but then I was thinking, well, this driver takes 4 outputs from an Arduino, because you need one for each of the 4 switches in here, and another input from the limit switch. So that's 5 inputs, outputs that you've used. It's very wasteful. Then I read about a type of driver that just needs pulses. In fact, one of these amazing things. What is it? An A4988. Absolutely incredible. I thought, oh look, that looks nice. That's nice and big and exciting, and you can connect the 2 coils. You can see them there, and it's got all sorts of options. But the main thing is, it does all the switching of the different things automatically. It knows which one to switch off and in which order. All it needs is a series of pulses, steps, so each time it receives a pulse from an Arduino, it moves the motor around 1 step, and direction, pretty self-explanatory. So I thought, well, let's order some of them, because that means I can halve the number of outputs that are needed from the Arduino, sort of. They duly arrived, and I was absolutely horrified and amazed. To my mind, electronics needs to be big like this, whereas these things are absolutely minuscule. It's incredible. I was very nervous. I'm nervous about little things like this because they're just too small. I could just break looking at them. But I duly wired one up, and they are amazing. And the other great thing about these is that they've got a current limiting potentiometer on it, so you can adjust. You connect up your stepper motor to it. You don't send through any pulses. You just keep the stepper motor on one, sort of wired up with 1 coil, and then you measure the current going to the stepper motor, and you adjust this until it's okay. Now these motors are 1 amp. I set this to, what was it? I think it was about 750 milliamps, about 3/4, just to keep it well inside. And because I don't need too much torque to move these things around, you know, it didn't really matter. So did that, wired it up. Amazing. A few little teething troubles through to my own stupidity, but they are absolutely incredible. Now I've obviously got 4 of these. I've got 1 wired up so far. Let's see what it does. Here we are. Here's the amazing little thing with one of its heat sinks glued or stuck with double-sided tape onto the chip itself. Cannot get over that, because I mean, this one's got a huge heat sink, but the switches in that one are so much more efficient that they don't produce so much heat. That's obviously connected to an Arduino with a little sketch to run that. Basically, a great thing is that the Axel stepper library, the Arduino library, which allows you to run all sorts of different stepper motors, but you can get them to speed up and slow down at the beginning and end of each cycle of movement, which is very useful. And it's got an option where you can tell it, the option 1, where it basically just outputs pulses and a direction signal, and all the other commands to get it to move are the same. Isn't that fantastic? So that's how that's wired up. I'm running that because obviously the motors take a lot of current, so they need their own supply, and I'm running that from here but without current limiting. So I've set that to 7 volts, dropped that down, which is about the minimum that the circuit will properly work at. So that's fine, no problem with that. And as I say, unlimited current, as much as you want. I've set that little potentiometer to 750 milliamps. Right, look at that. Isn't that amazing? So what it did, let me start that again because this is absolutely bonkers. It starts off, I've written a little sketch, it finds the limit switch, and then it will run to 100 randomly chosen frets. I just wanted to see what it looked like. Isn't that amazing? It's not too noisy. and it just does it. And every time it stops, it's actually lining up with a fret for 100 milliseconds and then moving on. Very thrilled, very, very pleased, thrilled, overwhelmed by that. Imagine 4 of them, absolutely crazy. Oh, and the other thing is that I've decided, because I've got to the stage where I've printed the 4 of them, because this was printed in brass filament, and I get the feeling it's not that, I mean it does give a lovely finish and all the rest of it, but I snapped off one of the small little pins that support the bearings, and I just think it's not up to that much. So here's the 4 I printed with the white filament, and I was umming and ahhing about it, what colour to make them, and I thought actually silver, because the silver pulleys at each end, and it just looked like a little bit too much brass. They're silver. Lovely. Can't wait to get them installed. But we've now hit a problem. Because I didn't do any research, I thought, oh, ukulele, how difficult would it be? You've got charts with chords and things like that, and you pluck strings, and I've got one. That's enough. What an idiot. Because I've now come, obviously, to the stage when I can start thinking about how to program chords, so that it will actually it will set the fingering into specific chord patterns. So I looked it up this morning. In fact, I woke up last night thinking, not in a cold sweat, but in a sweat of nervousness, thinking, hold on a minute, I've made some assumptions. Let me share with you the assumptions that I made, wrongly as it turns out. The first assumption was that the fret starts at this end on the charts, because I didn't bother reading anything. Turns out, because I did read something this morning, they start at this end. This is always on the charts the lowest or highest point. Now, the other thing I realised was, look, what an idiot I have been. That little bearing only goes up to this fret, it won't go any higher. Duh. So what I'm going to have to do is move these 2 motors further up. The other thing is, when they zero, they know where to go. They come down here, they touch the switch, and then they can move back to this first fret. That way, as they're tuning, whizzing about, they don't have to go anywhere near these switches. Oh, and I forgot to mention, thank you very much to the people on YouTube who suggested to reduce the volume I could use Microstepping. And basically Microstepping is incredibly clever. This driver circuit offers 1, 2, 3, 4, 5 different options. So full step, which is what I was using, if you connect these 3 input pins low, 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 down to 0 volts in effect, you get full step. So every time it receives a pulse, it does the 1.8 degrees or whatever, the full step. So you can feel it sort of, you know, a whole magnetic step in effect. So that's nice, but what you can do, you can ask it for half step, quarter step, 8th step, or even 16th step, and it does it in such a clever way. It's unbelievable. It basically feeds the two coils with different amounts of current, so they act to sort of sweep it round and hold it at intermediate parts between 2 of the whole steps. That's absolutely incredible. Down to 16. I mean, it's one of those mind-blowing scientific, technological things. How, with 2 coils that admittedly you can connect both way round, feeding them with different amounts of current can pull the centre of the stepper motor into 16 different steps per natural sort of magnetic thing. Incredible. What I ended up doing was to go to quarter steps. I had this running as fast as it possibly could, 200 RPM I think, or some. Anyway, I'm not even going to get into all that nightmare. Very fast, and then set it to quarter step. I started with 8th step, but it was too slow. So in the end I went to quarter step. It still made it much quieter, I suppose, because it's not clunking instantly into each of the whole overall steps. It's sort of gliding round magnetically. And that went fast enough. If I needed to go faster, I could have set it to half step. It's unbelievable. This is such a clever thing. It's all so clever. I'm overwhelmed. brief update and a top tip. Look, that's what I was talking about, moving them over a bit so they sit backwards, just two of them. So there's one for either side, and here's the new elongated ones of those. Hopefully this is focusing. There's the old one, and you can see this one goes further. How lovely. I used to use this sort of super glue always, just because I knew it worked. 10 grams of Loctite, whatever, no affiliation as always. And then my son used it all up in it, you know, blah blah blah, I mentioned it before. I ran out and I needed some urgently, so this time all I could find, these. This is 20 grams of it. Great, same stuff. Problem is, what sets off super glue is moisture. It doesn't dry, it doesn't whatever else, it's moisture. That's why it's very good at sticking fingers, because they're damp. If you leave a tube this big out and you keep regularly taking the top off and squeezing bits off, oxygen and moisture will slowly get inside and it probably won't last too long. The top tip is keep it in the fridge. Two very good reasons. There's no moisture in the fridge, or very little, because it all gets turned into ice, so it's very dry. Secondly, it's cold, obviously, so it slows down any sort of setting reactions, and also it means that whenever you take it out of the fridge to use, it's cold, so it doesn't set quite so fast. It gives you a little bit of wiggle room. Thank you. Another top tip, you heard it here, probably second or third, steam head. The dog's walked, the paint has been drying and is now dry, and prior to taking the dog for a walk, whilst the paint was drying, I've been mounting, well, I'm going to mount all four of these on a little bit of Veriboard that I had spare. I've cut all the little strips because it wasn't quite the right way round, but there's two of them mounted, which is very nice. Also thrilled to find that the outputs, that's these 4 pins here, actually correspond the right order for the pins and the little plugs on the stepper motor that come with them. Now it might be chance, although I somehow doubt it. I think some very clever people out there. It's a bit later and I've got everything back together. I can't tell you the excitement. This is brilliant. It now moves down further so that when the carriage comes down and touches the switch, it is further than needs to be for the bottom fret. And with the lovely new motor supports at the top, for these two at least, these two are fine because they extend right past it, this can now go past. Let me demonstrate. I'm still using the original one wired up to this one on the breadboard, but that's fine. So let me press the reset button on the Arduino. So it slowly goes down, finds the stop, and then again I've programmed it just to do random frets, and it does go part, it just goes up to the top one. Hopefully it will at some point. There we are, it did it. So I've now got access, and the bottom one without touching the switch. So I've now got access to all 13 frets as it turns out, not 12, 13. What an idiot I've been. I'm so pleased with that. And the way it works is, through experimentation, I've got positions for the 13 frets. So once it's moved to the bottom, to the switch, it then moves a little bit until it's in the right position for the bottom fret and then sets itself to 0. So 0 is the bottom fret, and then it can move all the way up to the top fret, perfectly aligned. That's incredible. And what I've got it doing at the moment is it just cycles. There's a quick function that just cycles, goes up to it, moves it 100 times, and it just keeps moving to a new position, a random position on the pseudo-random, just to keep some people happy, on the array. So it just whizzes around, waits so I can't say 100 milliseconds on each one, and then moves to the next one. What's going on now, you cry? Well, as always, all exciting stuff. I've got those 4 stepper motor drivers, the pulsed ones, set up there, and I've got them connected up to the Arduino. I've got the outputs over to the inputs. I'm just using the analog outputs or inputs or whatever on the Arduino as digital inputs, so that's absolutely fine, so I know where each motor is. And then look dear friends, I've got all 4 of them connected up with the drive belts and hopefully theoretically adjusted in the right place. So first thing, I've written a sketch, if you will. There's nothing clever about it. I'm sure there'll be ways of combining all these. There's 4 separate bits. It's the original little, where am I? I don't know where I am. There we are. It's this first little bit that just moves the motor. If it's touching the switch, moves it back, and then moves it back to touch the switch. Once it's touching the switch, it moves it to the 1st fret. Simple as that. And I've done it 4 times, 1 for each motor, because I have learned through hours of frustration in the past, etc, etc, not to overcomplicate things at this stage. I just want to check that it all works. I could combine functions and all this, and then I'd find it doesn't work and I have to go back. I've just realised, luckily, before I switched it on, that obviously these 2 motors have to go the other way around because they're the other side. So, dear friends, let's upload this, upload the sketch. Is it plugged in? Yeah, it's upload the sketch, and while that's uploading, switch on the 7 volts. Ooh, oh, cantoner. Ooh, how exciting! I never thought I'd see the day. That's perfect. That's exactly, so they're all now lined up with the 1st fret. Now I want to program them to do that crazy thing that I was testing this, just to see how to combine the functions and all the rest of it. The interesting thing is, I think it's interesting, is that the current draw now on this at 7 volts is 1.3 amps, because obviously all 4 motors are drawing about whatever that is, a quarter of that, which is fine. It holds them in place, which is great. You can see the screws, the adjuster screws that push on the micro switches, are standing well clear off them, about 3 or 4 millimeters, which is exactly what I wanted. So they're all now I've extended this way, they're all now happily sitting on the 1st fret or the last fret and not touching them. Upload. It's compiling, it's uploading. That's interesting. I think I might need a faster. I think I remember reading that the Arduino is 16 megahertz or something. It may not actually have enough speed to move all 4 stepper motors at the same time, because I noticed that they seem to be a bit faster when there's less of them moving. Right, but proof of concept, it is actually doing what I want. Yeah, look at that shooting up. But that I am very pleased with. That's the culmination of lots and lots of different elements, aspects, from wiring up all these little servo stepper motor drivers to all sorts of other things. But I'm very pleased with that. Next time I'm going to order an Arduino Mega, because I'm going to need loads of extra ins and outs for that. So I'll order one of them, which has got a much faster clock speed, sort that out, and then next time plucking, because obviously I need to pluck and strum them, or pluck or strum them in the right place. Lovely. Thanks very much for watching. It's been very exciting, and I'm actually getting there now. So pleased. I can't wait to see it all whizzing around really fast like the single one did before. Please, if you like this sort of thing and you're a glutton for punishment, please remember to click like and subscribe and the bell button if you want to be alerted to when my plucking and strumming video comes out. Heaven only knows. Looking forward to it though. Thanks again.